Welcome back. In our first video on exponential and logarithmic equations, I stopped before I was able to check the answer, so let's do that now. Here's the equation from the previous video, and here is the answer we reached. That is the exact answer. Let's calculate that approximate answer, because the approximate answer will be easier to check. In order to do this, you must be very careful to use parentheses appropriately for your calculator. It is very important to put in parentheses as appropriate for your calculator. Your TI-89 does not know what you've written in that numerator, so you have to say, hey, here is the numerator. And there's the end of the numerator. Put that entire numerator in a pair of parentheses. Also be careful to close that pair of parentheses, or once again, your calculator will not do what you want it to do. Okay, then hit the division button, which will give you a division bar, and tell it, hey, here is the entire denominator, by placing the denominator in a pair of parentheses. Okay, and once again, remember to close that pair of parentheses, or again, you will be calculating something different than what you want to be calculating. And if you have put it in correctly, you will receive as your answer negative 0.4791, which I always report with an initial 0 to draw attention to the fact that there is a decimal point there and you don't miss it. And that is the approximate answer for X. But now we need to check it. So to check it, we're going to go back into the original equation with this approximate answer, because it's much easier to substitute that than it is that whole big ratio that we got as our answer, the big fraction. All right, so what we're going to do is we're going to be calculating 2 times 4 raised to the negative 0.4791 minus 1. And we're going to also calculate what it's supposed to be equivalent to on the other side, which is negative 0.4791. All right, now what you need to do on your calculator, once again, how do you put it into the calculator? You're going to do 2, you're going to hit the times button, 4, caret, and you will need parentheses around this exponent. To put it into your calculator, you do not need the initial 0. You can do without it. And close parenthesis. That is equal to 0.2573. So that's the value on the left-hand side. And if you then do 17 caret parenthesis negative 0.4791 close parenthesis, you will get 0.2573, although your calculator won't have the 0 there. So it is true that one side is equal to the other. We have solved the problem correctly. This is the correct answer, and this is the correct approximate answer. So let's talk about logarithmic equations. We're going to be solving equations where the variable is trapped as the argument of a logarithm. We're going to be using one technique for solving logarithms. We're going to isolate the logarithm and convert to exponential form. Exponential form. However, there will be times where we have more than one logarithm. So first, we may have to use the rules of logarithms, the properties of logarithms, to combine all the logs into one. Okay? So then you get them into one logarithm, isolate that logarithm, and convert to exponential form. So let's do an example. All right, example 1, first one in this video. We'll take 2 times the natural log of 2 plus the natural log of x. Okay, so we have 2 logarithms in this. Oh, but wait, we have 3. Okay, now we're going to use the properties of logarithms to combine all of these. I see I can take this 2 that's multiplied by the natural log of 2, I can bring it in as a power using the power rule. I have a plus natural log of x here. I want to combine all these logs, so I'm going to have to subtract the natural log of 3 from both sides. Therefore, I'm going to have the natural log of 2 squared plus the natural log of x minus the natural log of 3, and only 0 is left on the other side. And now, look, I have a product that I can combine, so I'll get the natural log of 2 squared. I'm going to leave it like that, but of course that's 4 times x. I think my next thing I do will be to change that to 4. I don't think it's useful to keep it as a 2 squared. Okay, so we have the natural log of 4x, but I have a difference. If I have a difference of 2 logs with the same base, they're both natural logs, I can turn that into a quotient as the argument. Okay, so 4x over 3 equals 0. I have a single log now. I have isolated the logarithm in which my variable is trapped. So now I can convert to exponential form. I just have to remember that there's an understood base of e when I'm dealing with a natural log. So when I convert this to exponential form, I have e to the 0th power equals 4x over 3. Well, e to the 0 is just 1, right? And I can rewrite 4x over 3 as 4/3 x. So now I can multiply both sides by the reciprocal of 4/3, and I want to do that because then my 3's cancel, my 4's cancel over here, and I'm left with x equals 3/4. Done. Okay, so let's check our steps. Combine all of the logs into one log. Check. Convert to exponential form. Check. And when I combined all those, it isolated the logarithm too, so that gets 2 checks. And I then, probably another step we should go with is, because you almost always have to algebra, okay, to get the final answer. Let's check it. 2 natural log of 2 plus the natural log of 3/4 equals the natural log of 3. Well, let's see. Bring this in. Natural log, you could do this on your calculator also. Plus the natural log of 3/4 equals the natural log of 3. This is the natural log of 4, but I have a sum, so it can become a product. 4 times 3/4, that's like 4 over 1. Everything cancels. The natural log of 3 equals the natural log of 3. So I'm done, and I've checked it without a calculator. All right, so if I see these together, a whole mix of exponential equations and logarithmic equations, how do I know where to start? I can actually only give you general rules because each of you will find different ways to solve these things. And you'll start in different places, but usually I recommend these methods. With an exponential equation, usually you solve by taking a log of both sides. And I usually recommend that it's the natural log that you use. Okay, a logarithmic equation is usually solved by isolating the log, combining as many logs as you can, isolating the log on one side, to exponential form. So once again, just as they are inverse functions, they are almost inverse methods. Let's do an application problem. Okay. An analysis of population in Canada has returned this equation to explain the population growth of Canada. The log base 2 of 35.9 plus 0.0115 t, where p is the projected population in millions. Okay, and t is the number of years, since when? Since Canada was founded? No. Since or after 2015. So in our case, 5. So let's see what would happen in the year 2025. Okay? What we're going to do is get this log to the other side. We want all of our logs on one side, but we especially have to have the log containing the p isolated. So if we subtract the log base 2 of 35.9 from both sides, we will only have 0.0115 t left on the right-hand side. I have a difference of 2 logs. That means I can combine their arguments in a single log of the same base, and the arguments will form a quotient. And that's going to be equal to 0.0115 t. Okay. At this point, I have a single logarithm. I can convert it now to exponential form. So 2, that's the base, to the exponent of 0.0115 t equals p over 35.9. Now, there was one thing we had in our setup. We've already decided what the time is. We decided we want it in the year 2025. But what we need to put in for t, we can't put that in yet. We need the number of years since 2015. So 2025 minus 2015 is 10 years. So t equals 10. And that will go back in here. So now we actually have the following equation. We have 2 raised to the 0.115 equals p over 35.9. Now to find out what p is, all we have to do is multiply both sides by 35.9. And a calculator is called for here. So p is equal to 38.8788. All right? But we do know that we are talking about a projected population in millions. And when you're talking about populations that large, they're never exact. You always have a little bit of estimation built into any census. Go ahead and report this as the projected population of Canada in the year 2025 is expected to be 38.9 million people. Canadians. I will leave the check for you. We're not really using any new techniques. We're just applying them to the solving of equations. I'll see you in class.